Welcome to A-Level and AP Physics. In today's class, we will discuss March 2021 paper 1-2. There are 40 questions in this paper and the total time for this paper is 1 hour and 15 minutes. The total mark for this paper is 40. You will get 1 mark for each correct answer. If you need to do any rough working, you need to do on this question paper. There are 40 questions on this paper. Answer all the questions. You need to answer all questions, and there are 4 possible answers. You need to choose the best possible answer. You need to use soft pencil and you need to record your answers on answer sheet. Don't use any correction fluid. Don't write on any barcodes. You may use a calculator, means you can use calculator for this exam. Useful data is also given here. It simply means that some constants and the values are given. If you didn't remember any constant and you need for any questions to answer, you can come and you can find here. For AS level especially, you need to understand the value of G. The value of G you have to use in your exam, that is equal to 9.81 meters per second per second. You can also see some useful formulae also given here. This is formulae list. These are very common formulae. For example, you can look at the first one. This is what we need for AS level. I will just draw this rectangle around the formulae you need for AS level. This is also what you need for AS level. We don't need this one. This formula you also need for AS level here. Resistors in parallel, resistors in series you need for AS level. So these are the formulae you need for AS level. If you didn't remember them, you can come back and you can find them here. For AS level, you also need Doppler effect formula. Means Doppler effect equation you also need. If you look at this one at the bottom, you can see there is a plus and minus sign. So what's meaning of that? When to use plus and when to use minus? We need to understand if the source is approaching observed frequency, this one has to be greater than the source frequency, and this is true when the source is approaching. Source is approaching. So if the source is approaching, then you have to use the negative sign. Means the formula you have to write down, this will be Fs V over V minus Vs. So you have to use the negative sign here. When the source is moving away, then F observed has to be smaller than Fs, moving away. So we can write down when the source is moving away, then the formula you have to use F observed has to be equal to V over V plus Vs multiplied by the frequency of the source. Fs, S here is for source. So Fs is frequency of source, O for observed frequency, observed. So this is very important one you need to understand. First question is about reasonable estimate for the density of sand, and this type of questions are very common in this paper. Most of the time question 1 is about reasonable estimate. We need to understand how to approach this type of problem. The best way to approach this type of problems is comparison. Means you need to compare with something known. Comparison with something you already know. So we can write down comparison with something known. That is the key concept you need to understand to answer this type of problems. For this question, we need to estimate density of sand. So the best way to estimate density of sand is density of water. And density of water is about 1 gram per cubic centimeter. Now, next thing you need to understand, if we have, let's say, this is a glass of water, and if we place sand inside this glass of water, sand will sink and finally sand will stay at the bottom of the glass. From here we can conclude density of sand is greater than density of water. This is greater than density of water. Next thing we need to understand the density of mercury. Density of mercury is about 13.6 grams per cubic centimeter. meter. Now we need to understand the density of sand is much less than density of mercury. So we can simply estimate the density of sand can be around 2 to 3 times of the density of water, or simply we can say about 2 or 3 times. Even if you don't know it is 2 times, 3 times, 4 times, if you go through the options, you can find out the answer very easy. First of all, if you look at the first option, this is telling us density of sand is 200 times of density of water, so that is not possible option because the density of mercury is only 13.6 times. If you go to the second option, this is 2000, so this is telling us density of sand is 2000 times of density of water, that is also not possible. If you go to next one, this is 20 kg per cubic meter, so this is telling us the density of sand is 50 times less than density of water, so this is 50 times, or we can simply write down in a little different way. We can also write down like this. This is telling us this is 1 over 50 of the density of water. That is also not density of sand because sand is denser than water, so this is not possible option. If you look at last option, this is telling us density of sand is about 2 times of density of water, so this is a reasonable estimate, so this is our answer. Question second is based on physical quantities and the units. For this question we need to find out which physical quantity can have this unit. If you look at the first physical quantity, acceleration we can simply denote with letter A, and this is equal to force over mass. The unit of force is Newton and the unit of mass is kg, so it means this is not answer, so this is Newton per kg, so this is not possible answer. If we go to force, the unit of force is Newton and this is equal to kg meter per second square, kg meter per second square, so this is also not possible option. If we go to mass, for example mass, we can write down mass is equal to force over acceleration, so simply we can write down unit for force is Newton and the unit for acceleration is meter per second square, so this is meter per second square, so simply we can write down this is Newton second square per meter. This is correct answer. But if we look at momentum P, this is equal to mv, unit of mass is kg and the unit of velocity is meter per second, so this is also not possible answer, so the answer is C. For this question a velocity vector is given. As you can see here, the magnitude of the velocity is 75 and the angle with vertical, this is equal to 30 degrees. Question is asking us about the components of the velocity vector in north direction and also in east direction, so simply we can write down is asking us about vertical component and horizontal component. Vertical component simply is equal to V cosine of angle, means this angle, cosine of this angle. V in this case, this is equal to 75 and cosine of 30 degrees. Simply if we solve this one, this is equal to 64.9 meters per second. So this is our vertical component in this direction. We need to find out a horizontal component, that is equal to V sine of angle, sine of this angle, so simply we can write down this is 75 times sine of 30 degrees. In this case our final answer will be 37.5 meters per second, or approximately we can say this is equal to 38 meters per second, so this is correct answer. For this question, a micrometer screw gauge is used to measure the diameter of a copper wire. We have two diagrams here, diagram 1, diagram 2. Diagram 1 is when the wire is inside the jaws of the micrometer. So this is shown in diagram 1, means with wire. When the wire is inside the jaws of micrometer, we can simply write down this is with wire. This is without wire, when the wire is removed and jaws of micrometer are closed. This is without wire, so simply we can write down this is diagram without wire, when wire is not inside the jaws of micrometer, without wire. And if you look at this one, the reading on this is equal to 14, means the circular scale reading is equal to 14. So this is 14. If you multiply this one with the least count of micrometer, that is equal to 0.01 mm. So this is equal to 0.14 mm. And this is zero error, but this is positive. This is zero error, but this is positive zero error because this reading is greater than actual. So we can say this is positive zero error. So as you can see here, this is positive zero error. This is 0.14 millimeter. I have already written here. We need to understand how to read this. In this case, you can see the linear scale reading, that is equal to 2.5, and circular scale reading, that is 9. If you multiply 9 with 0.01, again you will get this is 0.09. Now we need to add these two, so this is our final answer. Mean this is the reading on this one. This is reading on micrometer. So we can write down reading on micrometer. This is reading on micrometer. But this is not the final answer, and this is not the diameter of the wire. In order to find diameter of the wire, we need to subtract this one because this is positive zero error. So this is the reading higher than actual. So we have to subtract. And our final answer is this. So B is the final answer. If instrument has positive zero error, it simply means that the measured value is always greater than actual value. Or simply we can say the measured value minus actual value, that is equal to positive zero error. So simply we can say that will be equal to zero error. All the readings will be greater than by this amount. Zero error is an example of systematic error because all the readings will be greater than actual value if this is a positive zero error, and if it is negative zero error, all the values will be smaller than actual value. For this question, current is given, the mean value of the current with absolute uncertainty is given. Potential difference, its mean value and absolute uncertainty is given. We need to calculate the percentage uncertainty in the calculated resistance. Now, first of all, we need to understand how potential difference, current and resistance, they are linked together. They are simply linked together by Ohm's law. This is very simple, Ohm's law. V is equal to IR, so R is equal to V by I. Now you can see these two quantities are divided. So it simply means that we need to add the percentage uncertainties to calculate the percentage uncertainty in resistance. For that reason, we have divided absolute uncertainty by the mean value of potential difference plus absolute uncertainty in I divided by its mean value. Multiply by 100, then just simply solve this one, and this is the percentage uncertainty in resistance. For question 6, it is given there are 4 cars A, B, C and D. They move from rest in a straight line. Cars take the same time to accelerate to a velocity of 60 kilometers per hour. The VT graph is shown in this figure. We need to find out which car reaches a velocity of 60 kilometers per hour in the shortest time. That is the main thing. First thing, now we need to understand what is area under VT graph. Area under VT graph, so let me write down here. Area under VT graph, this is equal to displacement. So simply we can write down this is equal to displacement. As cars, they are moving in a straight line, so displacement and distance, they are equal. So we can also write down this is equal to distance. The next thing we need to understand, the shortest distance. Shortest distance simply means that the smallest area, the smallest area. Now simply we need to find out the curve with the smallest area, means the VT graph for a curve which has the smallest area. So this curve, if you look at the D, this area is the smallest, so the answer is D. This question is about projectile motion. It is given to us that a cannon fires a cannonball with an initial speed v at an angle alpha to the horizontal. We need to find out the maximum height reached by the cannonball. This question is asking us about maximum height. So we need to consider vertical motion only. So we will consider vertical motion only. For this purpose, we will take upward as positive. Now, if we look at the initial speed, we can resolve into two components. So this is a horizontal component and this is vertical component. Vertical component is simply equal to V sine of alpha. And the second thing we need to understand, at the peak, V vertical means V final in vertical direction, that will be equal to 0. Now if we have these two, then we can write down the U means the initial speed, this is equal to V sine of alpha, and the V final means the final velocity at the peak, that is equal to 0. Now we also need to understand acceleration is equal to G, and direction of acceleration is always down, so it means it is negative because we have taken up is positive, so this one is negative. Next thing we need to find out the vertical displacement. Let's say this is S and this is equal to capital H, the maximum height. Now simply we need to use SWOT equation, so we can write down S is equal to V square minus U square divided by 2a. V is equal to 0, so simply we can write down this is 0 minus we have V sine of alpha square divided by 2g, but g is negative, so this is negative g. Now simply if we solve this one, we will get this is minus V square sine square alpha divided by minus 2g. So negative cancel, and our final answer is this one, and this is the maximum height reached by cannonball. So the answer is C. For question number 8, it is given that a ball strikes a horizontal surface with momentum P at an angle theta to the surface as it is shown in this figure. The ball rebounds with the same magnitude of the momentum at an angle theta to the surface. The ball is in contact with the surface for time t. We need to find out what is the magnitude of the average resultant force on the ball during the collision. So first of all, we need to understand how to calculate average resultant force. Average resultant force is equal to the change in momentum over time. But time is already given, that is equal to t, so we no need to worry about time, we no need to calculate. This is equal to t. We need to find out what is the change in momentum. So we need to find out P final minus P initial. Now let's say this is our P initial and this is P final. First of all, we will answer this question by resolving vectors into its component. Let's resolve initial momentum into its component. So if we resolve initial momentum into its component, you can resolve like this. So this vertical component is simply equal to P sine of theta, because this is opposite to the angle, so this is P sine theta. And with angle, this is P cosine theta. The same we need to repeat for this final momentum. So we can also resolve this one into its components. So this is horizontal component and this is vertical component. Horizontal component, again this is equal to P cosine theta, and vertical component, this is equal to P sine theta. We will check change in momentum in x direction, also change in momentum in y direction. First of all, let's try to find out change in momentum in x direction. We will take to the right as positive. So the delta P along x direction, this is simply equal to P cosine of theta, means the P final in x direction minus P initial in x direction. P final, this is P cosine of theta. P initial is also P cosine of theta. So final answer is 0. So there is no change in momentum along x direction. Let's try to find out change in momentum along y, means in y direction change in momentum. So simply we can write down delta P in y direction, this is equal to P in y direction final minus P in y direction initial. For that purpose we need to take one direction positive because one momentum is down. This component down, that is up, but we will take up is positive. So this component is positive and this one will be negative. Simply we need to plug in values. So P final, simply we can write down this is P sine of theta, and P initial, this is minus P sine of theta. Now minus minus, if we multiply, plus, so this is P sine theta plus P sine theta. Simply this is equal to 2 P sine theta. So this is the change in momentum. So we can simply write down this is 2P sine of theta divided by T. So our final answer is D. Now we will answer this question using the different methods. In the last method we have discussed how to answer this type of problem by resolving vector into component. In this method we will study how to answer this type of problem by adding vectors. Here we have two vectors. Let's say this vector is P1 and this vector is P2. We need to find the change in momentum because we need to find out the force, the average resultant force. This is equal to delta P over T. T is the same because in question it is given time is equal to T, but we need to find out delta P. Delta P simply we can write down this is equal to P2 minus P1. We can also write down this one P2 plus minus P1. Now from here it simply means that we need to add two vectors P2 and minus P1, and that will be equal to delta P. Now simply we need to add these two vectors P2 and minus P1. Minus P1 simply means that this vector has the same magnitude as P1 but its direction is opposite. What exactly it means? It means that P1 and minus P1, they have the same magnitude. Their direction is opposite because P minus P1 is a negative vector of P1. So this is our minus P1. Simply we need to add these two vectors, means P2 and minus P1. First of all, let me draw P2. So we will draw one line equal to this vector magnitude P2. So this is our vector P2. We will take this vector from here and place here. So this is our P2. Now we will repeat the same process for minus P1. So this is our vector minus P1. We can also adjust. So this is minus P1. We will place here. So this is how you can add these two vectors together. So this is minus P1. Now we need to find out the resultant vector. Simply you need to add these two vectors together. So this is the resultant vector. This is our vector P2. So let me label first of all. This is P2 and this is minus P1. The magnitude of this one, this is equal to P, and the magnitude of this one, this is also equal to P. And this vector, let me draw arrows here. So this is P2 and this one is P1. And this is our vector delta P, means the difference between these two. So this is delta P. Now if you look at P1, P1 is making angle theta with horizontal. So this angle is theta. We can simply write down this is theta and this angle is also theta. Now we can divide this one into two parts, this triangle. So this side means this half of that from here to here. So this will be equal to delta P by 2. And this half, this will be equal to delta P by 2. If we look at sine of angle, sine of theta, this will be equal to delta P by 2 divided by P means this one. From here we can find out delta P is equal to 2P sine of theta. So simply this is over delta P, this is equal to 2P sine of theta divided by T, and this is over answer. This is kind of typical question about Skydiver and terminal velocity. First of all, let's try to understand this question with the help of VT graph. So let me write here velocity on vertical axis and time on x-axis. So at the beginning, when the Skydiver will jump, velocity of Skydiver will increase like this. Finally, it will reach a terminal velocity. So at this point, we call first terminal velocity. Now, if you look at this one, you can easily understand velocity is increasing but the gradient is decreasing. It simply means that the acceleration of Skydiver is decreasing with time, and finally at this point acceleration is equal to 0, or simply we can say at this point mg is equal to a resistance, or we can say is equal to drag force. We can say simply is equal to drag. But for this question it is given to us opens his parachute. So when Skydiver will open his parachute, at this point velocity suddenly will decrease and again it will reach a terminal. Now we need to understand at this point why velocity decrease. Because when this Skydiver is falling down and suddenly open this parachute, drag force increase dramatically. This one is the drag, so this will increase, but weight remains same. So now acceleration is upwards, but still Skydiver is falling down, velocity is still down. In this case, Skydiver will slow down. Its direction is still downwards. So simply direction of velocity is still downwards, but magnitude of velocity decreases. That's the reason answer is A. For this question it is given a stationary firework explodes into 4 fragments, meaning into 4 pieces, which travel in different directions in a horizontal plane. Now first of all, stationary is very important. From here we can understand initial momentum is equal to 0. So the final momentum also has to be equal to 0 because this is an isolated system. So simply we can say that in any direction change of momentum has to be equal to 0. So we can simply write down in any direction delta P has to be equal to 0. This is the main concept we need to answer this problem. Now if you look at all these fragments, the angle between these vectors is 90 degrees. You can see this angle is 90 degrees, this is also 90 degrees. So it means that vectors are perpendicular to each other. We no need to resolve into components, or simply you can treat if you take this direction is x direction. So simply I can write down, let's say this direction is x, we can say this is y direction. So you can also write down like this. We need to find out the velocity of this fragment x. For this one it is given to us, we have the mass of this fragment, we have velocity. So simply we can say that 10g times 300 meters per second, this one has to be equal to 15g times, let's say, velocity v. From here we can find out that will be equal to 200 meters per second. So our answer is A.